Hello. In this C# video, I will be covering static members, which allow you to define data and methods that belong to the class itself rather than individual objects. Static members are useful when you need shared information or behavior that is common to all instances of a class, or when you do not even need to create an object to use the functionality. By the end of this video, you will understand how to create and use static fields, methods, and even static classes to make your code more organized and efficient. Let us start by answering the question, what are static members? Normally, when you define fields or methods in the class, each object you create has its own copy of them. But sometimes you need something that is shared across all objects, like a common counter, a utility function, or global settings. That is where static members come in. A static member belongs to the class itself, not to any individual object. Let us start with a code example, which is a static field. As you can see, we're in Visual Studio Code, and let us start by making a counter class. And inside the counter class, we're going to create a static field. So we're going to do that using public static, which is the keyword of note here, int count equals 0. Here, count is a static field. It exists only once, regardless of how many counter objects you create. You access static members using the class name. So let's make an example of that. So let's make a main class, a program class. And inside that, we're going to use our main. And then inside that, inside our main, we're going to first output our counter, or count from our counter. So we're going to do that by console.writeLine. And then inside writeLine, we're going to do counter.count. And then inside that, we're going to increment our count. And then we're going to print out the count again. So again, notice we did not create a counter object. Static members belong to the class itself. So let's open up a new terminal and take a look. Let's navigate to our program. And then inside that, let us run the program using .NET run. And it's going to take a second to compile, but first it's going to output 0, and then after we increment it, it's going to output 1. Our next code example is going to be a static method. So here we're going to make a new class called math helper. This is going to be an example of a static class. This is going to be an example of a class that has a static method, which can be called without creating an object. So let's do that. So let's make a math helper class. And then here we're going to define a static method that squares a number. So public static int square, and then we're going to pass in a number. And then we're going to simply return x times x. Inside our main, we can comment that out for now. We want to define a result, called an integer called result, and then that is going to be equal to math helper dot square, and let's pass in 2. Then we can output the result using console.writeLine, passing in the result. So again, static methods are perfect for utility functions like this, where you do not need to store any object-specific data. Now that we have this saved, let us run our program again using .NET Run. It's going to take a second to load, and it's going to output our result of 4. Before we continue though, I think it's important to understand the difference between static and non-static. It's important to understand that static members are shared. Only one copy exists. Non-static members belong to each object. In other words, each object gets its own copy. If you mix static and non-static members, you have to be careful because static members cannot access non-static fields or methods directly because they do not belong to any particular object. Now that we understand that, let us do our final example of a static class. So we're going to do a utilities class. So static class utilities, and then inside that, we're going to make a static function called greet. So public static void greet, and then we're going to pass in a name. And then what this is going to do is it's going to output, it's going to greet the user. So let's use this notation. Hello, and then passing in name. And then obviously end that off with a semicolon. Static classes cannot be instantiated. You cannot create objects of them, but you can call their static methods like this. So first, let us comment that out. We could just straight up do utilities.greet, and let's pass in a name. Let's make sure that's saved, and now we can run it again. And as you can see, it says, hello, Bob. So before we can conclude this video, let's do a quick summary and some takeaways. To recap, static members in C# have the four qualities. They belong to the class, not particular or individual objects. They are shared across all instances. They're useful for counters, global settings, or utility functions. They include static fields, methods, and even entire static classes. Static members keep your code efficient and organized when you need shared behavior or data. If you found this tutorial helpful, do not forget to like, subscribe, turn on notifications, and leave a comment. Reach out if you have any questions. Otherwise, thank you for watching and have a great day.